Alright, hey guys, so this is our first official video for chapter 9. You guys already watched the units one, but the rest of this chapter, or really this whole chapter, is looking at the different types of questions that we could see coming up on the AP exam. So everything we do is pretty much going to be based off of an FRQ. So the first thing we want to look at is the average value of a function. So we looked a little bit in class with that investigation, but now let's really talk about what an average value is. So there's kind of two ways that we can think about average value. The first one here, we're going to take a look at this graph. So this gray area here, we can see that that's the area under the curve, and we can kind of just say that this is A and this is B, which means really this gray area is the integral from a to b of f of x dx. And that's just the area that's there. All right, so what we're saying with this average value then is that the average value is the value of y that explains where a function would level off if we spread all of its area out equally. So what that means is if we took this gray area and we tried to level it off, this would be the value where it's all going to level off. And so really we can kind of see that, because if we take this area that's above that average value, we can see that it actually fits very nicely right down here, and it levels it off into kind of this nice rectangle. So that's one way to think about the average value. The other way we can think about it is to think about that when we calculate the average value of a function, we are essentially adding up all of the y values over the interval and then dividing by how many we added. So in other words, we're averaging the values. Hence, average value of the function, right? So let's see what this actually looks like. Let's check out this formula then. So we kind of know that if we're looking for adding up all the values of the area, then that means all we're going to do is we're going to take the integral from a to b of f of x dx. And we know that that's adding up all of the y values together. And then what we're going to do is we want to divide by how many we added, which really means we're just going to divide by b minus a, because we know we went from a to b. Well, this is the average value then of the function. Now, we don't generally see it in this form though. I am going to rewrite it into the form that we usually see in calculus, which is 1 over b minus a times the integral from a to b of f of x dx. And that's all the average value is. So let's look at some actual examples here so that we can see what this is going to look like on the AP test. So find the average value of the function f of x equals 1 plus x squared on the interval from -1 to 2. We're going to do it without a calculator, but then we're going to use our calculator to double check our answer. So what we can see here is we've got the function f of x, and we've got the interval from -1 to 2. So -1 is my a value, and 2 is my b value. So we know we're going to use this formula, 1 over b minus a, which means 1 over 2 minus -1. And then we're going to have the integral from a to b, so -1 to 2, of our function, which is 1 plus x squared, and then dx. So now we're just going to start to simplify and take an antiderivative. So let's see. This is going to be 1 over 3. That's my 1 over 2 minus -1. And I'm going to put brackets here because now I'm going to do an antiderivative. So let's see. We'd have x plus 1/3 x cubed. And we're going to evaluate that from -1 to 2. So 1/3. And we're going to start evaluating here. So if I plug in 2, I would have 2 plus 8 over 3. Ooh, and you know what I just realized? I forgot my plus c. I hope you guys caught that before me. Sorry about that. We need our plus c from our antiderivative. So 2 plus 8 thirds plus c minus, now if I plug in -1, I have -1 minus 1/3 and then plus c. So 1/3, and let's see, we know our c's are going to cancel, right? So we have 2 plus 8 thirds, and then this becomes a +1 and a +1/3, and we know the c's are gone. So it's a 3, and we know 8 thirds plus 1/3 is 9 thirds, which is just 3. So we have 1/3 of 6, which is 2. So our average value of this function over the interval -1 to 2 is 2. And we're going to use our calculators to double check this. So we're going to go ahead and I'm going to do alpha y equals for my fraction, and I'm going to do 1/3 because that much I can simplify on my own. And then we're going to do times, remember it's math 9 to get your integral, -1 to 2 of 1 plus x squared dx, and the answer is 2, so we know that we're right. Now you're not always going to be able to use your calculators on these, but there are going to be certain ones where you can, and so you're going to want to use them to double check your work and make sure that you're doing it correctly. Alright, we're going to do 2 more examples here that are good ones for you to have in your notes. So, when do we find the average value using that formula? So sometimes it's hard to figure out when we're going to use these, right? So what you have to keep in mind is that when a problem asks you to find the average something, all right, and I'm literally going to put the word something, and then gives you a function to describe that something, that's when we're going to find the average value. So it could be like in this example where they're giving you a function for temperature and they're asking you to find the average temperature, or it could be something where they give you a function for the cost and they ask for the average cost. But pretty much when you see the average of something, that's when we're going to be doing average value. So let's take a look at this first example. One day a strange weather system moved into town and the temperature in degrees Fahrenheit over the next 24 hours was given by this formula. T is in hours, and we can see we went from 0 to 24. What is the average temperature over that 24-hour time period? So this is the key right there. They're asking for the average temperature, and we're given a function to describe that temperature. So that's how we know we're going to be talking about the average value. So we know the formula is 1 over b minus a times the integral from a to b of f of x dx. So I'm going to go ahead and start plugging in what I know. I know that my a value is 0 and my b value is 24. So I'm going to have 1 over 24 minus 0 times the integral from 0 to 24 of this function. So 70 plus 2 sine of t over 2 minus t over 2. And since this is all in terms of t, I'm going to put dt because I want my variables to stay consistent. So I'm going to actually use my calculator to do this though, because it's going to be a lot faster. So 1 over 24, math 9, 0 to 24 of 70, 2 sine x over 2 minus x over 2, and then dx. Okay, there we go. So we get, remember, anytime we do anything with the AP exam, we're going to want 3 decimal places. So we know that this is going to be 64.026. That's going to be the average temperature over those 24 hours. So what we want to look at next is what would the units be, right? We just talked a lot about how to figure out what the units are for these problems. So let's think about what the problem gave us. They gave us this function t that's got temperature in degrees Fahrenheit. So the temperature in degrees Fahrenheit. And then we've got T, which is time, and that's measured in hours. So let's think about our average value formula. Sorry about that. We know that when we do an integral, we're talking about the area, which means when we did the integral, we did degrees Fahrenheit times hours. And in front of our integral, we've got this 1 over b minus a. And the b and the a are times measured in hours, which means in front of the integral, this 1 over b minus a really gave us 1 over hours. And so the hours cancel, and we're left with degrees Fahrenheit for our units, which means the average temperature is 64.026 degrees Fahrenheit, which would make sense. If we're asked for the average temperature, it probably should be the same units that we measure temperature in. Okay? Then we've got one more problem here that we need to talk about. So suppose that C of T represents the daily cost of heating your house measured in dollars per day, where T is measured in days, and T equals 0 corresponds to January 1st, 2010. So C of T is the daily cost of heating your house measured in dollars per day. And then we know that T is time measured in days. And T equals 0 means the first day of 2010. So we're asked to interpret 1 over 90 minus 0 times the integral from 0 to 90 of C of T dt. So hopefully you can look at this and you can recognize that this right here is the average value. That's exactly the same as this formula that we did up here, 1 over b minus a times the integral from a to b of f of x dx. And that's what we're given right here. So we need to be able to interpret this in terms of what's going on. Well, this is the average value of whatever this function is, and we were told that this function, C of t, represents the daily cost of heating our house. So we're going to start with writing what it is. So 1 over 90 minus 0 times the integral from 0 to 90 of C of t dt represents the average cost average daily cost, sorry, I forgot the word daily, because that's what it is. This is the daily cost, my bad about that. So the average daily cost of heating your house Now, that's kind of the first part of the answer, is we're saying that, hey, this is the average value function, right? So it's the average of whatever this function was. But we also have to talk about this 0 to 90. We have to talk about the time frame that they give us. So we said t equals 0 corresponds to January 1st. So we started on January 1st and we went 90 days. So really, this represents the average daily cost of heating your house over the first 90 days of 2010. And then the last thing we want to include is the units. So average cost of heating your house over the first 90 days of 2010, and then we're going to say that it's measured in dollars per hour. So when we do our explanation, like I said, it's kind of in these three parts. The first part is it's the average value of what? All right, then you're going to talk about the time frame. What does that mean for you in context? And then what is it measured in terms of units? Okay? The very last thing we're going to talk about here is how is this different then from 0 to 90, the integral from 0 to 90 of C of t dt? Well, we know that the integral means finding the area. So if we think about this function, we're given C of t, which is measured in dollars per day. And then we're given time, which is measured in days. So when we find the integral, we're finding the area, which means we're doing dollars per day times day, or days, whatever, and they cancel to give us dollars, which means this function right here that we're talking about, this integral then, the integral from 0 to 90 of C of t dt represents the total cost of heating your house the first 90 days of 2010. Can you guys still see? Okay, we're good. The first 90 days of 2010 measured in dollars. So the difference is that the average value is giving us the average daily cost, whereas when we're looking at just the integral, we're looking at the total cost of heating our house. But both of them have those three parts. What is it we're measuring? What's the time got to do with it? And what are the units? All right. Hopefully all of that made sense. You guys will get tons of practice with these average value functions. And then you can ask any questions you've got in class. I will see you guys later. Bye.